Get to the coastline.
In triangle KMN, so sometimes I don't even attempt to draw things to scale. I just start with a triangle and label it K, M, and N, and see what's given to me. I know this is 16, I know this is 11, and I know this is 6. It looks like I drew an equilateral triangle where all my sides are pretty much the same length, so it definitely is not to scale. Which angle is the biggest? N would be the biggest angle, and K would be the smallest. Okay? We want to find the measure of angle M. So I'm going to, at the top of this page, from your formula sheet, write the second form of the cosine law. The cosine law has two equations that are just the same thing written rearranged. So if you rearrange that formula to get the cos part by itself, you would get this. This is on your formula sheet. That cos of c is a squared plus b squared minus c squared over 2ab. And once again, we're going to highlight the only letter that appears on both sides, the only letter that goes with the c, and those are a side and opposite thing. Now we use this formula when we have to use the cosine law. Notice we have three pieces of information. Do we have a 90-degree angle? Maybe, but we don't know. It's possible, but we're not given any angles. So you're not allowed to use SOHCAHTOA or a squared plus b squared equals c squared. In fact, if you checked a squared, 36, plus b squared, 121, you get 157. And 16 squared is 256, so it's definitely not a 90-degree triangle. A squared plus b squared equals c squared doesn't work. Can we use the sine law? We have no angles. Sine law needs an angle and its opposite side, but we have no angles whatsoever. So we have to go to the cosine law, and if you're solving for an angle in the cosine law, we like to use this version because the angle's already separated by itself. Now, what goes together? What's going to go with the m? Right opposite is the 11. So as far as setting up your formula, I want to find m. I know that over here is where that 11 is going to go. Because the c goes with the c, so m will go with its opposite side, m. Where do I use the 6 and the 16? It doesn't matter. Because you're adding them. So you can just plug the 6 and the 16 in anywhere. The key is that 11 has to be there. The 11 is what needs to be subtracted because it goes with angle n. We could use the same thing and find angle n first. Question?
Is that a 11 squared?
Yeah, and it's in the formula. It is a c squared. I just forgot the squares up in the original formula. So from this, we can get a decimal answer for all of that math. I'm going to type that all into my calculator. Squared plus 6 squared minus 11 squared all over 2 times 6 times 16. over 64. Or you could write that as a decimal. According to our cast rule, positive, it's in quadrant 1 or quadrant 4. Based on the situation, can you see that quadrant 4 is not necessary? Because if you got an angle that was bigger than 270 degrees, you couldn't fit that in a triangle. So the only answer that would work is quadrant 1. Quadrant 1 is the same as the reference angle. So when I find the reference angle, second cos inverse of 57 over 64, my reference angle is 27 degrees. My angle then is going to be 27 degrees. Triangle stew, again, not drawn to scale. We are told that ST is 16. SU is 20. And TU is 6. And we want to find angle T. So once again, as far as the formula goes, if I want to find angle T, it's opposite the 20. So when I go to my setup, if I want to find cos of T, over here, the 20 squared is going to be what subtracted? 16 squared plus the 6 squared stays the same, and the 2 times the 16 times the 6 would stay the same. All those numbers, I like it when they make them so similar. Okay, so on my calculator, I can go up and steal this. The only thing I would need to change is the 11 should be a 20. So I just type over top 20. Saves me a lot of time. Push enter, and I get negative 9/16. Okay if you get a decimal. Now, according to the CAST rule, cos is negative in quadrants 2 and quadrants 3. But again, if you had an angle bigger than 180 degrees, it's not going to work in your triangle. So we know that our answer is in quadrant 2. So we would need to find our reference angle. Okay. And again, when finding your reference angle, we always plug in the positive. So your reference angle, and the reason it's important that I'm going to show you something after here, but I'm going to say the reason it's important that we do our reference angle is because you're going to do questions where you have to find quadrant 2 and quadrant 3. So as far as practicing wise, always find your reference angle first. Then how would I find the 1 in quadrant 2? Does it make sense that I would have 180 would be too far? I'd have to subtract my reference angle. And I get 124 degrees. Now I want to show you that when you do cos inverse of negative 9 divided by 16, when you do cos inverse of a negative answer, it actually gives you the answer. Wait for it. It actually tells you you made a mistake because you used the wrong negative sign. Let me switch it up. It actually tells you the answer in quadrant 2. But the problem of doing cos inverse of a negative is then you would not be able to easily find the answer in quadrant 3 because you don't have your reference angle. So it is good practice to find your reference angle first and then solve for the angle. But I will tell you, and in AP Calculus you have to know about domains and ranges of cos inverse, sine inverse, and tan inverse. If you do cos inverse of a negative, you always get an angle in quadrant 2. If you do sine inverse of a negative number, you always get, wow, that is not even close to a negative. If you do sine inverse of a negative number, you will always get a negative angle in quadrant 4, which is kind of confusing. And tan inverse also gives you a negative angle in quadrant 4. And there's good reason for that, but you don't need to know why yet. You will eventually. No, it's too much math with inverses and domains and stuff that we're not. If it was just a simple thing, like when I did the unit circle for the 0, 180, that was pretty easy. This one's more complicated. Okay, so we are going to add to this questions 5 and 7. And instead of going to example 3, maybe I'll get you to turn, there's a fair bit of space. We didn't do any writing on page 491, right? Where we did a little bit? All right, I'm trying to find some space where we didn't write very much. 492 has some, no, there's not, there's only a little, I want a little bit more space. 497 has a bunch of space? Sure. Although we might need it, we can probably do the question 4 above question 4. Sure, let's turn to page 497, and I want you to write new area formulas, because you know the area of a triangle. What is your area formula for a triangle? 1/2 base times height. Awesome. But sometimes you're going to get a triangle where you have something like this. And what's the problem if you wanted to find the area? You don't know the height. So if you wanted to find the area of this triangle, you would first have to draw a straight line down and find the height. Drawing a straight line down makes a 90-degree angle, so you are allowed to use SOHCAHTOA. And would you agree that if you had this angle of 25, the height is the opposite side, and you know the hypotenuse is 6? So what you could do is you could say that sine of 25 degrees is opposite side over hypotenuse, and then you could get the h by itself. Now mathematicians did this, ... so h would equal 6 sine 25. Mathematicians did this and they said, well, what happens if we use this idea for a formula? Let's say we wanted to create a formula where I knew the base. Whoa. Take out my eraser. That eraser's way too big. I'm going to erase everything and start again with a new triangle. And in my new triangle, I'm going to call my angle theta, this side B and this side A. What's the area of this triangle? 1/2 base times height. But what's the problem? We don't know the height. So we draw our height in here, and we could say, using SOHCAHTOA, because this is 90-degree angle, sine of theta is opposite over hypotenuse, so my h is equal to a sine theta. What's my new area formula? 1/2 base times height, but instead of height, usually in this formula they write the a before the b. This formula is on your formula sheet like this. New formula for area. Because if this is A, this would be B, this would be C, this would be angle C. It's on your formula sheet, and it's a new way of saying, if I give you a triangle like this, 32 degrees, this is 10, this is 12, you can not use this formula because you don't know the height, but now you could plug everything into this formula because you know the angle and you know the two sides around it. It's a very helpful area formula when you don't know the height. And then there's also one more area formula that, it is on your formula sheet. There is a special area formula when you know all three sides. What's the problem when you know all three sides? You don't know the height. If you know all three sides, you could use the cosine law to find the angle, and then you could use that formula. But there is a formula that just uses the side, and it looks like this. Area is equal to the square root of s times s minus a, s minus b, s minus c, where s is equal to a semi-perimeter. Perimeter is adding up all the sides. Semi-perimeter is half of that. All right, so I'm going to just do 2 examples, or until the bell goes. Find the area of this. It is as easy as 1/2 7 times 8 sine of 20 degrees. .58. That's how easy the formula is to use. If the angle's at the top, then the formula only works. Notice how the formula has all 3 letters, A, B, and C. So the angle has to be between. If the 8 was here, then you would, in this point, you'd either have to use your sine law to find the other angle first, or you could create a new formula for that situation. Oh, we won't do that. So that's how, that's part of the fun.
Should give a milkshake.
Yeah, for a milkshake, and I'll actually take you out. Give you 25 cents. Let's find the area of this. If this was 8, and this was 12, and this was 10. Then our semi-perimeter, if you add them all up, 8 plus 12 plus 10 divided by 2, our semi-perimeter is 15. And the area will be the square root of 15. 15 minus 8, 15 minus 10, and 15 minus 12. So we go to our calculator. Square root of 15 times 7 times 5 times 3, 39.69. So these formulas are nice, that you can figure out an area very quickly without having